wanted to explain a little bit about the research vlogs. So basically, these are the projects and researches that I did before, or maybe ongoing projects or future projects that are not confidential and they don't belong to any company, or I have the permission to share some information about them. And the purpose of this is just to provide some insight about the research and different projects, and explain a little bit about the steps that we take to develop something, or even what is the benefits of different systems that we provided before. Um, and I'm happy if you have any question I can answer, and basically let's keep in touch. For the first episode, I will explain a research project that I did in 2018, which the title was Contactless Heart Rate Estimation. So basically, we design and develop an algorithm for estimating heart rate using a simple camera that you can find in any household. So what you can see during this presentation is that what is contactless heart rate estimation, and what kind of factors actually influence this algorithm during the operation when you want to do the estimation using a camera or a video feed or whatever. And also I will explain a little bit about the applications that we actually use this method in. So before we go further and we actually go through the presentation, let's see what exactly we are going to see during this presentation. So first, I will briefly explain that what is actually the contactless heart rate estimation and basically how it works. And then also I will explain the method that we proposed and actually tested through the research process, and also the projects that we did with that algorithm. And later on during the presentation, I'm gonna review a few of these projects that we use this method in them. So, for example, infant monitoring, estimating user stress and heart rate monitoring of a user to improve the user experience when during the gaming or during any other activity, basically using the computer when they are using a computer. And also a project about estimating or calculating or estimating the trust factor in robot human interaction. And lastly, a search and rescue drone that uses the heart rate to actually um, prioritize the patients or report back how critical their situation is. So, contactless monitoring of heart rate, um, actually resting heart rate, is an interesting avenue that can open up a lot of possibilities in different applications that I mentioned few of them before. So one of the common approaches for estimating heart rate using a camera is to monitor the micro variations in skin color. Basically, with every heart pump that your heart do, your skin color slightly changes in a very short time due to the blood flow that is pumping through your skin. So if you can detect these sudden macro changes in your skin tone, you can easily monitor the heart rate or estimate the heart rate. Uh, Interesting, huh? But and it seems quite easy, but there are some challenges that you need to address during this detection and convert it to the estimation. The factors that can influence your heart rate estimation um, are countless, but there are few important factors that you need to address when you want to apply, you want to use this method in a specific application, or you want to design a new algorithm. It's important to at least be aware of these factors so you can have a solution for some of it, if in your case is influential. For example, surrounding objects. Surrounding objects by themselves actually don't affect that much the estimation, but if their shadow um, change the lighting condition on your face, because we use face for heart rate estimation, especially the method that we propose, so that can be problematic. Or if they have if they affect the lighting of the environment that you are in, that can affect your calculation. The head movement, of course. Head movement, when you move your head, your algorithm is tracking it, but it can affect the result. And facial expression. So during our research, we saw that these kind of um, facial expression, whether you are happy, angry, whatever, or even if you like move your mouth, it can, if you don't have any solution for it, it can affect your estimation, and it can even make it inaccurate. And the most important one, lighting condition. So lighting condition should be like consistent in your footage. If you change the lighting condition, whether you add it, remove it, or your scene become brighter or darker, it can affect your estimation. And based on our research, if uh, for making your algorithm accurate enough, you need to have a good lighting condition and good camera. So basically, the quality of footage that your camera provides can affect the result, your result. So it's better be aware of that when you want to prepare your setup. As I mentioned, many factors can influence the result of your estimation, and the most important one is the lighting condition. So the lighting variation can affect the temporal and local pixel intensities in your footage. So you can see here um, a figure that actually exists in the in our publication, in our paper. So the you can see the you can see the brightness average of the green channel, and after we did the illumination rectification, and you see that in good condition, in normal, or in poor condition, how these macro motions and how these variation actually uh, could be detected. You see, in a really good condition, you see a lot of variation, while in in poor lighting condition, those variations are become invisible for you. Also, in this figure, you can see how facial expressions can actually influence your results, because when you do when you act surprised, or you laugh, or you become angry, the movement of your facial part can mess up your calculation, because uh, all you do is working with variation, macro motions. So big changes or any change can add error to your estimation. Here is also another interesting figure that we included in our publication. So basically, we compared our estimated heart rate with the heart rate that measured by a contact sensor during different situations. For example, when it's a normal illumination, or is the good condition in your illumination, or whether how the algorithm behave in rigid or non-rigid motions. So in normal illumination, you see our result is really close to our target result, or the um, heart rate that actually measured by the contact sensor. But in weak illumination, the result is all over the place, because it shows that the algorithm had a poor performance, or basically it wasn't accurate. And during rigid motions, you see that okay, these motions didn't affect it, affected but didn't affected the result that much. But with non-rigid motions, the algorithm again messed up the calculation, and the algorithm couldn't do a really good job estimating the heart. So here we actually show the steps that we we need to take from the moment we receive the footage to an accurate and reliable estimation of the heart rate. So first, we detect the facial landmarks using CLM algorithm, and we use these facial landmarks to separate three areas: forehead and two cheeks. These are the best places for detecting the macro changes in your skin tone, and from there you can estimate your heart rate. Later, we also added an algorithm for di- differentiating between a fake face and a real face. So if you put a photo of a person in front of the camera, the algorithm tell you that okay, it's not a real person or something like that. At the time, it was we thought that it's a good thing to add to the system because we wanted to use for different applications, and it shows the algorithm. It shows to the user. It actually provide a better user experience if the algorithm can actually differentiate between a photo and a real person. After that, we do some pre-processing before we go to the estimation process. Well, basically, first we convert the image into a signal like time series data by averaging the different channels, and also we use interpolation method to make the curve and make the signal smoother, because not because it's more presentable, it's just and that way you can see the peak points better, or you can detect the peak points better. You can see the figure here on the top right, after and before the after the interpolation process and before the interpolation process. You can see the result there. After that, uh, we have other pre-processing step for removing non-rigid motions, also basically make the signal better for our estimation process. And later we use the radical algorithm, which is a better version of ICA, or independent component analyzer method. I suggest you use this method. At that time, it was the most novel one because it's really tolerant toward the outliers. So if you have any application that you need an ICA, maybe try to use the radical one. We got really good result out of this algorithm. And later we use, of course, FFT to bring our signal to a Fourier domain, and then we detected the peak points, as I mentioned, because when you have the peak points, then the distance between them time wise would be your pulses. And after that, we filtered out the frequency outside. Well, frequency, I mean, in Fourier domain, you have the frequencies, not the spatial information. So we removed anything else except the area that we are interested in, which is the heart rate thingy. And we used also a temporal filtering to remove any extra, any outlier or anything that can is not um, our heart rate. And we extracted the frequency with the highest magnitude as our basically our heart rate. So at this point, you have your estimation, but We added another step which helps the system to provide more reliable and consistent measurement during your test or for your system. As I explained before, many unwanted factors can affect the measurements. So although we added many steps, as I explained before, to prevent the effect of these factors, regardless, they can have adverse effect. So what can we do to address this issue? We design a data fusion method that calculates robust and reliable results by using different measurements of heart rate that we did from independent sources. What is independent source? Are the areas that we did the estimation. So we have three areas that we use for our estimation: the cheeks and the forehead, and we calculate the heart rate for each of these areas separately, and then we use a method to find the best estimation out of these three and combine them together. Also, we provide, let's say, confidence factor um, along with our data fusion thingy based on like a Gaussian distribution. It's a confidence factor that we show how reliable the estimated result is. And since a normal heart rate, a resting heart rate for adult is between 60 to 100 resting heart rate. So we actually define a Gaussian distribution with for calculating the confidence factor with 80 as a mean and 30 as a standard deviation. And we provide the confidence factor for each measurement based on that. Also, let's see what else we have here. Okay, and also we have a predefined threshold, um, which we define based on the environment that we have, and we will remove the result or skip the result that are their confidence factor are lower than our expected like our lower than our expectations. So the highest factor, the highest, and we use the highest confidence factor to update our regression model that I will explain later for our fusion. Okay, now that you know a little bit about how the system works or how our algorithm works, let's go review some of the applications that we use this algorithm for. The first one is infant monitoring. So in this project, we design and develop an infant monitoring system that helps the babies sleep better. And we also provided the parents with the live heart rate, and also we could detect the crying and report the parents if the child is under stress. The system also had a camera that monitored the baby's face and also record, of course, estimate and record the heart rate, and the parents could see the result, the stress level, and the heart rate. The next application that we did, we designed and developed a user monitoring system that monitors the user's heart rate and stress level while they are working or gaming using the computer. The system can help actually the user to have a healthier and more effective experience while they are working with the computer. Also, it can help parents to monitor their kids' stress level while they are gaming, which is very important. One of the interesting topics
Stand
in
up.
robotics these days is estimating trust.
Stand up.
But what does it mean? So it's basically the trust factor is how um, for example, in a situation that a disaster happened, so let's say an earthquake happened or there's a fire or something like that, so we deploy robots
Please
to
come
go and
closer.
assess the
I
situation,
want to
and they
estimate your
interview
heart
people,
rate.
they communicate with people to see which one really needs help or maybe gather information. And the robot needs to, well, it's better to have an estimation how much you can trust a person based on their vital signs and different things. So in this research, we actually tried to do something like that using an algorithm combined with a lot of different algorithm and sensors to estimate the trust factor.
Your heart rate is 61.
Okay. Sit. Sit.
Thank you.
Last but not least, we use our heart rate algorithm in a search and rescue um, let's say system application, in a search and rescue application. So we designed a system for drone-based search and rescue that uses a heart rate estimation algorithm for initial assessment of detected humans. Let's say they there there is a report that few people have problem really in a really remote area, and you can deploy drones while the first responder are trying to reach that place, so the drones can go there and assess the situation and provide information about the severity of their injuries or something like that. So basically it was the initial idea that we wanted to do.